These are the answers to the 17 through 27 odd in section 0.5. They're from the textbook, and I'm going to step by step solve them so that you can see how it's done if the answers online were insufficient. So for the first problem, you need a common denominator to add fractions together. The denominator you want to choose is x plus 1 to the higher degree, which is 3/2. And you can turn the second fraction into a fraction with that denominator if you multiply it by x plus 1 to the first degree over x plus 1 to the first degree. That's the number 1, but it'll turn the second denominator into x plus 1 to the 3/2 because the way you multiply is adding the exponents if it has the same base. And 1/2 plus 1 is 3/2. So your second fraction will turn into 2 times the quantity x plus 1 over that denominator that we wanted. Your first fraction already has the denominator that we wanted. And so now they have the same denominator. You can combine them over that denominator by putting the negative x together with the 2 times the quantity x plus 1, which is 2x plus 2 when you distribute. If you add in your numerator any like terms, you will end up with x plus 2 over x plus 1 to the 3/2, which is the way you'd want to leave your final answer. Number 19, same idea. We need a common denominator. Right now the denominator of that second part is 1. So we want to multiply it by 2 square root of 1 plus t over itself in order to get the denominator that we want of 2 square root of 1 plus t. So my first fraction doesn't change. My second fraction will now have the denominator I wanted when I multiply 1 times that. And in the numerator, I'm going to multiply the square root of 1 plus t times 2 times the square root of 1 plus t. The way that you multiply that is you look at the two things that can be multiplied easily, and that is the square root of 1 plus t times itself, which is just 1 plus t. Any square root times itself, you end up with what's underneath the radical. So that's going to simplify to 2 times 1 plus t. And that's what our numerator is going to become in our second fraction. We have to be very careful about this subtraction because what comes after it is a binomial. So when we put these two together, we have to remember that it's 2 minus t, which is this first numerator, but it's minus whatever you get when you distribute through. So it's minus 2 and it's minus 2t when we distribute this 2 into the parentheses. Combining up our numerator then, the 2 and the negative 2 can add to 0. The negative t and the negative 2t can add to negative 3t. And our denominator is what we wanted it to be from the very beginning. Number 21. We're going to do the exact same thing one more time. We need to combine inside the parentheses with a common denominator because the order of operations says I'll do the parentheses first before I do this division. So I'm going to have a common denominator of the denominator in my second fraction, which means I need to turn this denominator into the square root of x squared plus 1 by multiplying it by the square root of x squared plus 1, and I have to multiply the numerator by that as well. So the denominator of my new fraction will be the square root of x squared plus 1. In the numerator, I'm going to do the same thing I did up here. I'm going to take my square root of x plus 1 times the other square root of x plus 1 that I'm multiplying by, which will become x squared plus 1. And I have this 2x out here that is also going to be multiplied on. So the numerator of my fraction will become this 2x times the x squared plus 1 I get from multiplying these two radicals together. Now I have a common denominator, So now I can put these two together over that denominator by subtracting. So I have a 2x cubed plus a 2x minus an x cubed when I distribute through here. And I'm going to change this division to multiplying by the reciprocal so that I can finish this problem out, multiply my numerators. This numerator simplifies down to x cubed plus 2x when I combine like terms. Multiplying that by the number 1. In the denominator, when I multiply a square root of x squared plus 1 times an x squared plus 1, I have to remember that they are the same base, and I'm going to add their exponents. The exponent of a square root is a 1/2. The exponent of this is the number 1. So when I add the 1/2 power and the 1 power, I'm going to write my denominator as x squared plus 1 to the 3/2. On 23, I already have my denominator, common denominator, so what I'm going to do is look in the numerator for common factors that might be able to factor out of this big expression. And I have an x squared plus 2 factor here and an x squared plus 2 factor here on opposite sides of my subtraction. So I'm going to pull out x squared plus 2 to the lower one of those, which is negative 1/2. I'm going to put my brackets and figure out what's left after I pull that out as a common factor. And in front of my subtraction, I have x squared plus 2 to the positive 1/2. This is negative 1/2. So I subtract my exponents. 1/2 minus negative 1/2 is 1. So in front of my subtraction, I will have x squared plus 2 left. After my subtraction, if I subtract exponents, negative 1/2 minus negative 1/2, I get 0, which means I pulled all of those factors out, but I still have this x squared left that I have to put inside my brackets. It's left, I didn't pull it out. Denominator x squared. Because this is connected by multiplication, this term here, or this factor here, can move to the bottom with its negative exponent and join the x squared. But I need to simplify inside here to see what's left for my numerator. X squared minus x squared is 0, and I still have this 2 left. So that's the numerator of my answer. Number 25, I need to combine like terms in my numerator with a common denominator before I deal with this other denominator. So it's a complex fraction, but the first thing I need to do is combine these over a denominator. In this case, the common denominator that I have to use is the product of these two because they have no common factors. So I'm going to turn both of the fractions into fractions with the square root of x times the square root of x plus 1 as their denominator. The first fraction, I needed to multiply on the square root of x plus 1. So I'm going to multiply that also on the numerator so that I can come up with an equivalent fraction. When I multiply the square root of x plus 1 times itself, I end up with x plus 1. On the second fraction, I needed to multiply on a square root of x. So I'll multiply the top by square root of x, and the numerator of the second fraction will become x. So now I have a common denominator in this numerator, and I will pull them together over that common denominator by taking x plus 1 minus x in the numerator. And x plus 1 minus x, it turns out to be 1. And my 2 over x plus 1 is still in the denominator of my complex fraction. So now we have a 3-story building, and what we do is we collapse the 2 bottom stories together over the numerator that's there. So my final answer will be 1 over 2x plus 1, And then I'll have the square root of x and the square root of x plus 1 down there as well. And I said final answer, but it's not, because now I have a common, a factor of x plus 1 here and a factor of x plus 1 here. This is to the first degree, this is to the 1/2 degree. So I'm going to multiply them together by adding their exponents, just like I did up here. And I'm going to add their exponents together so that I'm going to have x plus 1 to the 3/2 instead of an x plus 1 and an x plus 1 to the 1/2. They'll combine together. My final problem, to get a common denominator here, it's going to be a lot like number 17. I'm going to multiply the second fraction by 2x plus 3 to the first over 2x plus 3 to the first, because I can turn the denominator of the second one into this denominator I'm writing now, 2x plus 3 to the 3/2, if I multiply on that extra factor. So I'm going to have 2x plus 3 to the 1/2 times 2x plus 3 to the first, adding your exponents, that creates the 3/2. And my numerator, I'll have the 2x that was there times this 2x plus 3 that I'm multiplying on. Common denominator, 2x plus 3 to the 3/2. I have a negative x squared here, and I'm going to add on a 4x squared when I distribute, and a 6x. Combining up my like terms, I get 3x squared plus 6x all over 2x plus 3 to the 3/2. And that's my final answer. So those are the worked out solutions for the problems that should help you as you go to do the assignment that you're going to turn in on Friday that will be graded. If you have any questions, you can feel free to text me or call me or email me.